Yeah, I appreciate the intro. I'm Riad. I'm the CEO at Cubist. I'm also faculty at Carnegie Mellon. I think about cryptography, ZK proof, stuff like that. And actually, validators are very close to my heart. I ended up working on some of the earliest cryptographic infrastructure for ETH2 and others, designed like the hash-to-curve algorithm that's used inside the VLS signature scheme, and then ended up helping write the standard for that. So it was all kind of down in the weeds and the guts, but I promise I won't talk about boring stuff like that today. I'm gonna talk about security, really, security for validation. What does that mean? And this, I'm gonna mostly focus, I'd say, on chains that look a lot like Ethereum, and I'm gonna use Ethereum as a specific example, but really, this applies generally to things that are built on top of Ethereum, like restaking, other protocols that look like Ethereum in the sense that they use slashing as a security mechanism. So let's start there. Let's talk about slashing. So from the point of view of the protocol, slashing is, well, I mean, what is it? It's basically a mechanism that punishes behavior that's dangerous to the consensus process, right? It's there to say, look, you are incentivized to do the right thing and you're disincentivized from doing the wrong thing. And that's basically the idea is, look, you're economically, if you're a rational actor, your decisions will be driven by, this is what makes me the most money, and the things that get you slashed are things that would be potentially exploitable if not for the fact that, well, you lose a bunch of money if you get caught. The other thing that it happens to do is that it rewards people for watching. Right? If you're watching the chain and you see somebody do something that's slashable, in Ethereum anyway, somebody who includes a slashing event in a block is rewarded for that. So you get a little bit of money just for watching and making sure that people are behaving. And so in a sense, slashing is like the fundamental security mechanism for Ethereum. It's the thing that makes sure that the incentives for the validators are compatible, which in turn makes sure that the consensus mechanism itself works correctly. So again, from a protocol designer's point of view, this is what slashing is. It's like this very clean mechanism for kind of terraforming the reward landscape. But from an operator's perspective, slashing looks very different. From an operator's perspective, slashing is the sword of Damocles. It's like, well, if I do something wrong, then I get punished really badly for it, right? So even if I'm honest, if something happens that causes me to double sign, or in the case of Ethereum, something like a surround sign or whatever it might be, boom, I lose a whole bunch of money. And so this means that as an operator, I have to walk kind of a fine line, because obviously I want to have as much uptime as possible. If I'm not validating, I'm not getting rewards. In the case of Ethereum, I actually get a little bit of punishment for downtime. But a lot of the things that I might do that would help me with uptime, in fact, would get me slashed. Like, well, you might say, in the general case, like, well, if I really need to be up, I'm gonna run 2 machines. But of course, if you do that on Ethereum, life becomes ugly for you pretty quickly. So this leads to like a little bit of a conundrum. And well, our friend Destroyer of iPhone from Reddit put it, I think, pretty well. It's ludicrous, Destroyer of iPhone says, to penalize for downtime while shunning high availability best practices. Well, I'm not sure if that's ludicrous. That's ludicrous, but so the problem here is that we actually have this weirdness, right? We have a case where the mechanism that secures Ethereum is the same mechanism that makes life bad for operators. If you do something accidentally, even if you're honest, life becomes ugly. Okay, so let's think specifically. What is it? What happens when I get slashed? Like, what does it look like in reality? Well, let me give you a few examples. Oops, not the nicest formatting, but that's okay. I think you can read it. So a few real-life examples. First, I want to say, a lot of times when there are big operators who get slashed, they do something that I think is really brave and really nice, which is they write a post-mortem about it. They detail, this is what went wrong, this is what we're gonna do to fix it. That's great. It helps the whole community to get smarter, and it means that everyone can learn from someone's mistakes. So we're gonna learn from 3 mistakes that have happened in the past couple of years. A very recent example, about a month ago, there was a slashing on Ethereum. It was the result of kind of a weird data center failover case. There was a data center, it was running some validators, an operator was running some validators there. So the data center started to have weird network connectivity issues, and so the operator said, oh, I'm gonna move my validators to a different data center, to my backup data center. And the operator was using Web3 Signer, which is this piece of software that actually handles the signatures for the validators. It was using Web3 Signer, and in fact, there was a single instance of Web3 Signer that both data centers were pointed at. And so in principle, there should have been no slashing event because Web3 signer should have been able to say, no, somebody requested a double signature. That's not right. But unfortunately, Web3 signer was incorrectly set up, which is an easy accident. It's like a one-line change in a config file. And the result was, oops, when I did my failover, I got slashed. Well, not me, but somebody, like there we go. Okay, so that's one example. A second example is earlier this year, there was this Prism bug that it was kind of a subtle thing, but an operator said, well, I have one validator machine and I want to move some keys from that machine to a different machine. So the operator said to the first machine, please stop using these keys to validate. The machine said, okay. And the operator said to the second machine, okay, now these are your new keys, please use these to validate. And the machine said, okay. And so everything was great, except that the operator went and upgraded the software on the first machine and restarted it. And at that point, the first machine said, oh, look, I found these new keys. I better validate for them too. Those were the keys that it wasn't supposed to be validating for anymore. And this was because of a bug in Prism where it said, I won't validate for these keys anymore, but that didn't stick through a restart or something roughly like that. So Prism fixed their bug, but of course that doesn't bring back the 20 ETH or whatever that was lost in the slashing. And the third example of this this is a bit older, maybe a couple years ago. There was an operator that had that had some was doing some performance tuning on their validators, and they noticed, oh, there's a bunch of I/O issues. I'm seeing a lot of I/O when I went for my validator database. And so the operator said, well, you know what I'm going to do? I'm going to improve the I/O speed by moving the anti-slashing database into memory. And that's great. It definitely improved the I/O speed. Everything was happy, except that now that database is ephemeral, which means, in some corner case where you stop and then restart again quickly, maybe you lose some data from the anti-slashing and you re-sign a block that you've already signed, and now you get slashed. And that's indeed what happened. So these three examples, I like these because they kind of give us this perspective on what has happened. It was a minor, really kind of totally innocent mistake in a kind of esoteric corner of the setup. It was a bug in a really complicated piece of code, Prism. It was somebody made some performance tuning decisions that seemed innocuous, but because they didn't understand every aspect of the system, oops, they got slashed, right? So, okay, but all of these so far seem like, well, these are just operational issues, and I promised at the beginning that we were going to talk about security, so what the hell am I talking about? Well, this is what I'm talking about. If you can accidentally slash yourself because of misconfiguration or a software bug or whatever, that means that an attacker can in principle slash you too. And this is kind of weird because imagine that you're instead an operator for something like, an e-commerce site, right? You push new code to Netlify, and the result of that code is, something messed up and your site goes down for a few hours. But the result of that is not that all of a sudden your customers' credit cards are leaked to the internet, right? Like somehow you set up your site in a even marginally reasonable way, and you're PCI compliant and whatever it is, and you're pretty sure that an operational issue is not going to expose a whole bunch of credit cards. And yet here, in the context of validators, what we have is that operational issues actually become potentially security issues. If an attacker can get a hold of your DevOps password and can start up a second cluster, which seems like, oh, that's helping me. They're starting up more machines for me. No, in fact, they can slash you. And so the reason that this is maybe something like a security vulnerability is because what we're starting to see in the community is talk more and more about ransoms, about, well, I'm going to slash you unless you pay me money, or I'm going to slash you because you're running a pool that I don't like, or I'm going to slash you just because I like to see the world burn. So ops issues become security incidents. So obviously, we need to fix that in a few different ways. So one is, well, there's table stakes, like secure your keys. Great, that makes sense. But even that's not enough, right? If your keys are secured, but somebody gets a password that lets them, change the configuration in your Kubernetes cluster. They never saw your keys, but they could still slash you, right? So this is kind of ugly. This is actually uglier than what I said before. It's not just that the security mechanism for Ethereum is a headache for operators. It's that a security mechanism for Ethereum is actually the fundamental insecurity mechanism. It's like the way that you would attack an operator is by getting them slashed. Okay, so we've talked a lot about slashing. That's kind of the main sequence of an Ethereum validator. There are other, kind of small issues that I want to touch on that kind of highlight other kind of weirdnesses and complexities, and those have to do with deposits and withdrawals. But okay, look, an obvious thing first. If you're about to deposit, somebody gets a hold of the deposit wallet that holds your stake, and they steal that money, you're already sunk. That's an obvious one. Let's talk about something more interesting. Let's talk about front running. So this is an attack on essentially the deposit flow of, it could be against you, it could be against a staking protocol, but basically it all depends on a kind of an idiosyncrasy of ETH2, and that is when you make a deposit, If you make a second deposit afterwards, if the withdrawal credentials of the second deposit are different than the first, it's just silently ignored. The first deposit withdrawal credentials wins. And if you change that in the second one, nothing happens. And this is, I mean, there's a justification for it in the design of Ethereum. Like, it would be hard to make this not happen, but that doesn't help you. You still get messed up by this. And so the idea here is basically, if you can somehow get ahead of somebody who's going to deposit for an address, you can set the withdrawal credentials for that address, and then once they've deposited, you can withdraw their money, right? So this was something that several pools were vulnerable to. If you've pre-generated keys and those get stolen, those could get sort of somebody could steal your money by essentially front-running you to a deposit there, and then later withdrawing. Okay, so this is kind of ugly and weird, and again, it's because of a complexity in the system. Let's talk about exits. Again, if somebody gets your exit validator or your exit with credentials, life is bad. But there's another kind of, this isn't an attack, maybe it's more of a griefing style thing, but it could still take you down if you're something like a pool, and that is, exit stampede is what I called it here. So in that case, what we have is that a lot of pools tend to do this thing where they ask validators, or, operators that they've devolved validation responsibilities to, they ask them ahead of time for an exit message that's pre-signed, so that the pool can, force a particular operator to exit if they, do something badly, or if they're not getting good, if they're getting a lot of misses or whatever it might be. So there are these messages sitting around, and those messages basically could be used to command all of the validators in a pool to exit all at once. And if you did that, then what you would have is the pool would stop making money, and it would sit there waiting for all of its validators to be withdrawn. And if it's a lot of validators, the queue gets full, you end up waiting a long time. But then if you want to start staking again, you've got to push those validators back into the entrance queue, and you've got to go through a bunch of rigmarole to change the keys and all of this sort of thing. So this is not this isn't a huge takedown, but it's probably gums up the works for a month or so. So it's clearly a kind of griefing style attack, and it's definitely something that you want to worry about if you're running a big pool, or if you're worried that somebody just doesn't like you. Okay, so these are a bunch of different things that could happen, and the question is, can we somehow make all of these things go away? Can we just fix the system so that these things are not possible? And I think that the answer is yes, and there are probably a bunch of different ways, but I want to talk about one, because as was mentioned at the top, we work on key management infrastructure, and so we've been thinking about what does it look like to make a better abstraction for Ethereum keys. And so, like I said, this is one solution, and probably there are others that are interesting too. But so the idea here is, what if you could build a key that just can't sign a slashable block? Well, how would you do that? Well, you would make sure that the key basically can't be accessed except through some kind of, well, maybe you'd call it a guard, or maybe you'd call it a policy layer, and that policy layer is able to look at the history of what this key is signed, and it's able to say yes or no, right? It's an anti-slashing policy, very much like Web3 Signer, but it's different in the sense that you cannot access the key except through this guard. Right? And so the way that you do that is you actually enforce that using secure hardware. You enforce it using HSMs and trusted enclaves. And the idea is then your key presents this abstraction. There is one key, it lives in the sky. The only way to access it is through this one interface that will make sure that I can't slash. Right? And if you can do that, then you can be sure that no matter what happens in any part of the rest of your software, you will never, ever, ever get slashed. You can't misconfigure it because you can't turn off the policy. You can't accidentally spin up 2 copies because the abstraction is there is one key and it lives in the sky. And of course, in reality, it's globally replicated in all of this, but all of that can be hidden behind the abstraction interface. Okay, and then finally, other policies that are very similar can be used to prevent things like front running and exit stampede. For example, you might say, well, if you want to exit 100 nodes, you better give me an MFA approval for that, right? So this is one idea, but I want to be clear, again, there are plenty of others, and this is the reason that we've been spearheading this idea of a secure staking alliance. So earlier this week, we announced that a bunch of companies are putting their heads together, and we're thinking about things like, how do you build better infrastructure? How do you design new restaking protocols? How do you make sure that when somebody is starting to build a new validator network, they can somehow, they can get insurance for that because they're following best practices. What are best practices even mean? This is the kind of thing that we're trying to answer with the Secure Staking Alliance, and it's something that I think is going to become more and more important as we start to see even more, different types of approaches to validating as we see restaking, new AVSs, things like Babylon and Eigenlayer, where you have fundamentally the same threats of slashing, but now you have even more different sorts of variations on that theme. So with that, I think I'm just about out of time. The Secure Staking Alliance, there's a link for it there. Again, I'm Riad, I'm at Cubist, and we're thinking about validator security. So thanks very much for the time.